Good day and welcome sa another video lesson natin for Chemistry for Engineers. So sa previous video natin, we've talked about energy. We defined energy. Napag-usapan din natin ang energy transformation and conservation ng energy, ang heat capacity and calorimetry. And so we continue with lesson number 1, energy and chemistry, by defining the word enthalpy. Sa previous lesson natin, sa part 1 ng video na to, we said that energy flow can either be through heat and work only. So pwede lang mag-flow ang energy through heat and work. And sa mga ma-encounter nating circumstances or mga examples dito sa chemistry, work is usually the pressure volume work. So we can express that mathematically in an equation wherein the change in energy is equal to heat plus work. And since yung mga ma-encounter nga natin dito includes pressure volume work or pressure times the difference in volume or change in volume, pwede nating palitan yung work doon. And sa mga problems na ma-encounter natin dito, sabi nga natin is that work is done by the system. Kaya yung ating pressure volume work dyan ay negative. So one interesting scenario here is kapag ginawa nating constant yung volume. Since yung work natin is a pressure volume work which includes change in volume, kapag ginawa natin constant yung volume, that is, the change in volume will be equal to 0. So itong part na ito ay magzi-zero. And therefore, mapapansin natin that for constant volume processes, yung change in energy is equal to heat alone. Walang work done kasi nga constant yung volume, there is no change in volume, there is no pressure volume work. So yung subscript na V signifies that this is the heat at constant volume. Okay. But what happens kapag yung pressure naman ang ginawa nating constant? So doon nasisingit yung enthalpy. So we define enthalpy as energy plus pressure and volume. H yung ating symbol for enthalpy. And for constant pressure, we can say that the change in enthalpy equals change in energy E plus the change in the product of pressure and volume, diba? Okay, nilagyan lang natin ng change lahat. Siyempre kung anong gawin natin sa right side, ganoon din gagawin sa left side, and vice versa. But since sinabi natin na constant pressure ito, kasi alam na natin mangyayari pag constant volume, what happens kapag constant pressure? Okay. From our definition ng change in energy kanina, pwede nating palitan yung delta E, change in energy, to become Q minus pressure volume work or P delta V. Ito yung equation natin kanina. Moreover, since pressure is constant, sabi natin for constant pressure, okay, yung P dito will not be affected by the change or the delta sign. So that means pwede natin yung i-factor out. Kasi hindi naman siya affected, hindi naman siya magbabago. So for constant pressure, mapapansin natin lalabas ngayon si P kasi there is no change in P. And mapapansin natin magkakaroon tayo ng expression na change in enthalpy equals Q minus P delta V plus P delta V. This is the same but they have opposite signs. So makakancel. And that means for constant pressure, the change in enthalpy is equal to the heat alone. Again, Yung P na subscript signifies constant pressure. Ang ibig sabihin na nito is we now have two ways para ma-define yung heat flow into a system. So, under two different sets ng conditions. Una, kapag constant volume, yung measurable heat flow natin is just equal to the change in E, which is a change in internal energy. Kapag yung process naman ay constant pressure, yung measurable heat flow natin is equal to the change in enthalpy. So, in many ways, enthalpy is the more useful term because constant pressure conditions are common. So, there are two types of processes when heat flow is concerned. Kapag yung heat ay lumabas sa isang system, then tinatawag siyang exothermic process. And sa exothermic processes, the change in enthalpy is less than 0. Kapag heat naman is absorbed by the system, ang tawag natin doon ay endothermic processes. At for endothermic processes, the change in enthalpy is greater than 0. So, ano ba ang kahalagahan kasi ng enthalpy? Okay, take note na sa mga substances, change in temperature or heat flow into a substance does not always raise its temperature. Kung merong flow ng heat kapag ininit natin ang isang substance, hindi laging ang ibig sabihin nun is tataas na yung temperature or magkakaroon siya ng increase in temperature, di ba? For example, kapag meron kang ice at 0 degrees Celsius, syempre ice yan. So kung solid yan na ice, I mean kung kakayelo pa lang ng tubig, magiging ice yan, and magiging ice lang siya at 0 degrees Celsius. Pag in-applyan natin yan ng heat, what happens is that, of course, the ice will melt and it will become liquid water. But ano ang temperature ng liquid water as it melts from ice? Yung liquid water na yun is still at 0 degrees Celsius. Okay, darating yung point na magme-melt yung ice pag in-applyan natin siya ng heat into liquid water, pero yung temperature niya is still the same na 0 degrees Celsius. At kapag continuous yung heat flow, kapag patuloy nating ininit, yung liquid water na 0 degrees Celsius magiging liquid water pa rin, pero this time mag-i-increase na yung kanyang temperature. So ibig sabihin nito, yung heat flow into a substance, yun nga, does not always raise its temperature. May mga times na anong nangyari, hindi napalitan, hindi nag-raise yung temperature, pero what happened? Dun sa ice, naging liquid water siya. Nagkaroon siya ng phase change na tinatawag. So I hope you still remember yung mga phases ng matter. Diba meron tayong solid, liquid, and gas. So, ibig sabihin noon, although hindi raise, hindi nag-increase yung temperature, there is still heat flow. So sa bawat phase change, there is still heat flow. So paano ngayon yan? Paano na yung temperature ay nagre-remain constant kahit na merong influx of heat? Okay? Tandaan natin that there are intermolecular forces. So although hindi change yung temperature, there is still intermolecular forces na kailangang i-overcome nung heat para palitan yung phase. And as for example, para ma-melt yung ice into liquid water. And that still consumes energy. Kailangan mo pa rin mag-apply ng energy doon. Kailangan niya pa rin ng energy para ma-convert yung phase or magkaroon ng tinatawag na phase change. Ma-convert yung ice into liquid. By the way, ito yung mga common phase changes na alam natin. Yung solid, liquid, and gas, yung tatlong, at saka yung mga processes that involve between the change in phase between each other. So from solid to gas, tawag natin doon is sublimation, and ang kabaliktaran niya, gas to solid, is deposition. From solid to liquid, kagaya nung ice natin kanina, melting ang tawag. Yung kabaliktaran niya, from liquid to solid, is freezing. Gas to liquid is condensation, and from liquid to gas is evaporation. Ito yung mga processes ng phase change natin between solid, gas, and liquid. So going back, although hindi nag-raise or nag-increase yung temperature natin, kailangan mo pa rin gumastos ng energy para ma-overcome yung intermolecular forces to change the phase of the substance. And to be specific, yung intermolecular forces are more extensive in solid than in liquid, 'di ba? Kaya nga ang itsura ng solid is compact siya, 'di ba? Yung arrangement ng molecules compact, closely packed sila, in comparison with liquid na medyo loose sila, kaya they take the shape of the container, 'di ba? And syempre yung gas, siya yung pinaka loosely packed in terms of molecule spacing. So para ma-change yung phase natin from solid, which is extensive yung thermomolecular forces, to liquid na less extensive, kailangan nating ma-break yung mga intermolecular forces na yun, and that consumes energy. So doon yun yung reason kung bakit kahit na merong influx of heat, hindi nag-change yung temperature. Kasi yung unang pagpasok ng heat, ang una niya munang gagawin is to overcome the intermolecular forces. Once na na-overcome niya na yung intermolecular forces, na convert niya na yung ice into water completely, that's the time na, assuming na continuous pa rin yung flow ng heat, that's the time na mag-i-increase na yung temperature. So dito magkakaroon tayo ng mga panibagong terms, sabihin na natin mga specific names sa mga ganitong klase ng phenomenon. So yung delta H na merong subscript na FUS, yun yung tinatawag nating heat of fusion, and it is the heat that is required to melt a substance. Kagaya ng nangyari doon sa ice, minelt natin para maging liquid water. Meron din tayong tinatawag na delta H na may subscript na VAP. Ang ibig sabihin nun is heat of vaporization naman. So it is the enthalpy change or the heat required para ma-convert naman yung liquid papunta sa gas. So it is always positive kasi kailangan papasok lagi yung heat, diba? Kapag yung tubig pinakaluan natin, nagka-create siya ng steam, nagve-vaporize siya. So kailangan mo lagi ng heat. Pumapasok lagi yung heat. Ibig sabihin nun, yung direction niya papunta sa system. So positive lagi yung heat of vaporization natin. So itong mga to nakadepende sa type ng material na gamit. Syempre yung in-example natin is ice. That is water, H2O. But nakadepende yan sa klase ng substance. Iba-iba yung heat of fusion at heat of vaporization, heat of condensation, yan, ng mga iba't ibang klase ng materials. But usually water naman, di ba? When we are talking about hydroelectric energy, syempre water yung gamit. Kaya ito yung mga values ng para sa water. So yung heat of fusion ng water 6,009.5, heat of freezing, delta H freeze, syempre kabaliktaran yan. Fusion is melting. Pag magme-melt, papasok yung energy. Di ba pag mini-melt natin, iinitin natin. So, positive yung heat of fusion. Yung kabaliktaran, base dun sa pinakita nating picture kanina, ang kabaliktaran ng melting is freezing. But, yung energy na kailangan mo, same lang. Kaya mapapansin nyo, 6,009.5 pa rin yung energy. Yun nga lang, negative na yung direction kasi nga opposite direction na sila. Ganon din kay vaporization and condensation. Ang kailangan energy or ang heat of vaporization ni water is 4.07 times 10 raised to 4. Positive siya because papasok yung heat. Para ma-condense naman yung water, ang heat of condensation niya is negative 4.07 times 10 raised to 4. Again, the same numeric value but they have opposite sign because that is an indication of the heat flow. Kung papasok yung heat, positive. Kung palabas, negative. But again, kagaya dun sa Q equals MC delta T natin, wherein the change in temperature varies or is directly proportional to the amount of substance present, ganun din dun sa change in enthalpy natin. So, yung change in enthalpy natin sa phase change is also directly proportional doon sa amount ng substance. So, ang formula natin for the change in enthalpy present in phase changes is N. N is again the amount of substance in moles times delta H or yung heat of, depende na yan kung heat of fusion siya, heat of vaporization, condensation, or heat of freezing. So, depende na sa phase change. Ito yung mga yun. Ito yung mga gagamitin. Constant naman yan. So, for water, ito yung values. Kung merong ibang substance other than water na given, i-provide naman yun doon sa problem. So, let's solve an example regarding enthalpy changes in phase change. Calculate the enthalpy change when 240 grams of ice melts. So, yung formula natin is delta H, enthalpy change equals number of moles, amount of substance, multiplied by delta H, depende sa phase change. So, ang sabi niya nito is melting. So, that is heat of fusion. By the way, parehas lang ang ibig sabihin ng melting sa fusion. Okay? Hindi siya heat of melting. Heat of fusion ang gagamitin, pero same lang yung ibig sabihin ng fusion sa melting. So, ang heat of fusion, ice yan. So, that is H2O. Water yung pinag-uusapan natin yan dyan. So, ang gagamitin natin is yung given kanina. Ang heat of fusion ng water is 6,009.5. Okay? Walang problema. Ang magiging adjustment ng nagagawin natin is that yung N dito, remember, that is the amount of substance in moles. However, yung given is 240 grams. So, we need to convert 240 grams in moles. So, dapat alam natin yung molar mass ng mga substances. So, I hope yung maalala nyo pa. To convert 240 grams na mass in moles, kailangan natin i-multiply sa kanyang molecular mass or molar mass, gram per mole, or moles per gram para makancel yung gram, matira na lang is moles. Kasi yung given na heat of fusion dito sa ating binigay na 6,009.5 is in joules per mole. So, paano ba natin ko-convert yun? Basic chemistry yan. Sana naalala nyo pa. Ang chemical formula for water is H2O that comprise, ibig sabihin nun, water comprises of 2 atoms of hydrogen and 1 atom of oxygen. ano ba ang atomic number or atomic mass ng hydrogen, di ba? That is approximately 1 gram per mole. Yan yung, and then for oxygen is 16 gram per mole. So pag kinuha natin yung water, we have 2 times 1 dahil dalawang hydrogen, tapos isang oxygen, 16, that is 18 gram per mole molecular mass ng water. So ibig sabihin sa bawat mole, 1 mole is 18 grams of water. So mako-convert na natin siya. Magiging moles na yan kasi makakancel ito. So we have 240 divided by 18. That is 13.33 moles of water. So ready na tayong i-substitute ulit para makuha na yung change in enthalpy. We have 13.33 moles of water multiplied by the heat of fusion ng water. Base doon sa given table kanina is 6,009.5 positive fusion yan, multiplied in joules per mole. So cancel din si mole dito. So the change in enthalpy is equal to 13.33 times 6,009.5 will give us 80,106 80,106.635 joules, or approximately 80.11 kilojoules. Ganun lang siya. So generally naman, yung mga phase change nagte-take place siya at constant pressure. So pwede nating sabihin that heat flows should be viewed as changes in enthalpy. Kaya in-express natin yung heat or energy required sa phase change as delta H, or change in enthalpy. So ngayon, meron na tayong dalawang klase ng heat flow, di ba? Yung isa, yung Q equals mc delta T, energy or change in heat due to change in temperature. Tapos yung isa naman is itong phase change, which is equal to, or which is connected to the change in enthalpy or enthalpy change. Pag pinat natin yung dalawang iyon, so kapag kinumbine natin yung plot ng temperatures versus heat flow, makikita natin ito yan, yung graph natin. So as for water ito, as the temperature increases, so linear yung pag-increase from -50 to 0 degrees Celsius na temperature for water. Okay, ito yung heat na kailangan in kilojoules sa ibaba. So habang tumataas yung temperature from -50 degrees Celsius to 0, nag-increase din linearly yung heat na na-absorb, and then magkakaroon siya ng phase change ngayon. So sa phase 2, dito sa number 2, yung completely horizontal line na yan yung una nating phase change, which is melting. So from ice, magme-melt na siya into liquid water. Mapapansin nyo kaya siya straight line is that, di ba nga, pag phase change, hindi mag-i-increase yung temperature, constant yung temperature. Pero again, mag-expend tayo ng energy dyan due to overcoming intermolecular forces. And then kapag nag-continue yung heat flow at 0 degrees Celsius, kapag completely water na yung ating sample, pag in-increase natin yung temperature, mag-start na ulit siyang mag-increase ng temperature from 0 until ma-reach na yung 100 degrees Celsius, which is the boiling point. At boiling point, kukulo na yung tubig, and then it will start to become or start to vaporize or become steam. So again, we have a flat line again, which signifies again phase change. No increase in temperature, but there is a change in phase. Mapapansin natin itong number 4 that there is a large amount of energy sa steam kasi ina-absorb niyan, di ba? As we go to the right, as the temperature increases, yung sample natin or yung sabihin natin water, nag-absorb siya ng heat. So at steam, kapag steam yung water natin, there is actually a large amount of energy ang kailangan natin para magkaroon ng steam. Or inversely, sa mga steam, there is a large amount of energy. Yun ngayon yung in-exploit, yun yung sinasamantala ng mga hydroelectric power plant na tinatawag natin. So ginagamit yung high energy na steam para mapaikot yung mga turbines. Okay, what happens is, kagaya dito sa diagram natin, we have nagbo-burn tayo ng fossil fuels. Usually that is coal or natural gas. Yan, sinusunog natin siya, tapos ang challenge dito is dahil pag sinunog natin yung coal or natural gas, it releases chemical energy as heat, di ba? Combustion yan, so magre-release siya ng chemical energy as heat. So the challenge is actually ma-convert yung energy na yun, chemical energy through heat, papuntang electricity para ma-consume natin tao. So what's critical here is paano mo itatrap ngayon yung given heat doon sa pagsunog natin ng coal or natural gas para mas lalong maging efficient. So ang aim natin, matrap natin as much as possible para ma-conserve yung energy as much as possible. Yung lahat ng heat sa pagsunog ng coal or natural gas is magamit natin, may transfer natin, ma-convert natin into electricity. Doon papasok ngayon yung tubig. So, kung isipan kasi natin kung bakit tubig ang ginagamit, water yung ginagamit dito, it's because kung babalikan ko lang yung graph natin dito, this is the graph for water. Mapapansin natin that at steam, nasa between 1,400 in kilojoules na yan, to 1,600 kilojoules yung steam natin. Ibig sabihin, mataas yung heat of vaporization ng water. Ibig sabihin, mataas yung kaya niyang i-absorb na heat. Okay? At syempre, kung mas mataas yung kaya niyang ma-absorb na heat, mas marami rin siyang madi-deliver na energy, mako-convert into electrical energy. So, ang kailangan mo kasi dyan, mataas na heat or mataas ang heat of vaporization, and water is the only candidate. Merong mga ibang materials or substances, species if you may, na mataas din ang kanilang heat of vaporization, higher than water actually. Pero hindi mo siya pwedeng gamitin kasi they are chemically toxic. Chemically toxic sila, so they are not environmental friendly. Yun yung isang advantage din ng tubig kung bakit ginagamit siya sa mga hydroelectric power plant. It's because it's environmental friendly. Nare-recycle pa siya, di ba? Kagaya ng nakikita natin sa diagram. Bumabalik-balik lang. Papunta sa river, tapos ipapump dyan siya pabalik. Tapos, syempre, mas abundant ang water kasi water is everywhere dito sa earth. Pwede ba nating gamitin yung kung hindi pwede yung mga mas matataas na heat of vaporization kesa sa water, pwede ba natin yung gamitin yung mga mas mababang lower heat of vaporization? Siyempre hindi, kasi based dito sa ating formula, N times ayan, change in enthalpy, which is ito yung magiging energy na mako-convert natin, is directly proportional to the amount of substance. So if we compare water with other substances with lower heat of vaporization with the same amount of enthalpy change na desired, gusto nating enthalpy change, kung mas mababa yung heat of vaporization, that means to compensate, we need more of that substance. We need more amounts of that substance with the same amount of enthalpy change being considered. So mas madami ka dapat hanapin, mas marami kang gagamitin ganoong substance, kung ano man yun na merong lower heat of vaporization, para lang makompensate. Again, water ang pinaka-abundant, mas abundant kaysa sa ibang materials. So kung hindi pa yun, kung yung resource or yung substance na gagamitin mo pa is non-renewable, may hihirapan ka pa kasi mauubos siya. So again, that is not environmental friendly. So the best choice talaga is water. That is our material of choice. So bukod doon sa heat sa phase changes, kasi yun ay na-consider natin, di ba? So far ang na-consider natin is mga enthalpy change or heat flow on physical phenomena. So how about chemical reactions? The thing is, there is also enthalpy changes sa mga chemical reactions, and we call them heat of reaction. Meron siyang specific na tawag. So, yung heat of reaction is the enthalpy change sa mga chemical reactions. Remember, sa bonding, di ba, maraming types of bond. Chemical reactions involve energy changes because yung chemical bonds natin are broken and formed when reactants are transformed into products. So, pag nako-combine tayo ng mga species or substances to form new species or substances, ano ang nangyayari doon? Ang nangyayari doon is yung existing bonds doon sa reactants are broken and then rearrange, parang sinusolve mo ulit yung puzzle pero iba na yung form, fino-form mo siya to form the products. Kung maalala nyo yung chemical equation, reactants will yield products. To be able to form the new substances or the products, kailangan mong i-break muna yung bonds that is existing within the reactants. And the breaking and forming of new bonds will actually generate energy changes. So for example, ito, we have methane. Alam naman natin na kapag sinunog yung methane or what we call combustion process, kung nagkaroon ng combustion, that is pag dinagdagan natin ng oxygen yung methane, it will create a product of carbon dioxide in gas form and water. So methane, CH4, methane gas, kapag hinaluan natin ng oxygen is siya ang magsusunog dun sa methane, magkakaroon ng combustion, and then ang product natin, we have carbon dioxide as gas and then water in liquid form. So kung mapapansin natin, kapag sinulat natin yung Lewis structure nitong chemical equation natin in burning methane, kasi natin dun sa bandang reactants, we have 4 single bonds ng carbon hydrogen. So, ito. Carbon, hydrogen, single bonds. Diba? Kung matatandaan nyo, sa Lewis structure natin, bawat line dyan signifies bond. So, we have 4 single bonds or single CH single bonds dun sa reactants. And then, we have 2 double bonds for the oxygen. So, double bond, dalawang linya, 2 moles. So, 2 double bonds. And then, dun sa product, meron tayong ilan? CO na double bonds din, dalawa, isa, dalawa. And then, sa OH, meron tayong OH bond, single bond, OH single bond, tapos meron tayong coefficient na 2, so 2 times 2, 4. 4 na OH single bonds. Ang nangyayari kasi dito sa mga chemical reactions is that lahat ng bonds dun sa reactants, kailangan nating ma-broken down yun. And it will require energy. So, ibig sabihin, mag-absorb siya ng energy. So, sa reactant na part, this is endothermic. Kasi, yung bond breaking, kailangan mo kasing i-break yung bond, is endothermic process. Kasi kailangan natin ng energy, merong input energy to break the bond. And then, dun sa product naman, kailangan mo naman siyang i-form. So, form naman. So, bond forming. Dun sa bond forming, magre-release naman siya ng energy. So, exothermic naman siya. Opposite sila. Kasi kung kailangan kung may mag-release, may mag-absorb para ma-conserve yung energy. Law of conservation of energy. Again, ulitin natin. Pag nagpo-form tayo ng bond, if yung energy sa pag-form ng products is greater than the energy para ma-break yung bonds sa reactants, exothermic yung entire process. Okay, yung entire chemical reaction is exothermic kasi mas malakas yung form. Pero kung yung forming natin will yield less energy kesa dun sa breaking ng bond sa reactants, endothermic naman yun. Endothermic yung buong process natin, yung buong chemical reaction. Okay? Ulitin ko, kapag i-consider lang natin yung reactants, dahil kailangan mong i-break yung bond sa reactants, yung breaking is an endothermic process. Dun sa product, magfo-form tayo ng bonds, and forming bonds is an exothermic process. But kung i-consider natin yung buong chemical reaction, that is the reactants and the products combined, kailangan nating i-compare yung energy na na-absorb o na-give off between forming and breaking, between reactants and product. Kung mas mataas yung energy sa pag-create o pag-form ng products kaysa sa pag-break ng bonds doon sa reactants, yung buong chemical reaction is an exothermic process. Pero kapag yung pag-form ng bond sa product is less than sa pag-break ng bond sa reactants, yung entire chemical reaction is an endothermic process. So, pag pinagsama natin, usually, kapag dinagdag ko yung sa tabi ng chemical equation, yung enthalpy change. Okay? Yung enthalpy change na dyan, pinagsama na yan dun sa reactants and products. So, buong reaction na yan. Pag itinabi natin yung enthalpy change, which is for this example is negative 890.4 kilojoule, ang tawag natin dyan is thermochemical equation. So, ito yung thermochemical equation natin. Yung buong yan. Yung buong chemical equation which represents the reaction and at the same time, yung enthalpy change na nandyan. Napaka-helpful ng thermochemical equation kasi bukod sa makikita mo yung mga species or substances nandyan, makikita mo din yung energy and especially yung sign ng enthalpy change kung negative o positive siya. Siyempre, yung negative, ang ibig sabihin nun, naglabas siya ng heat or energy. Palabas yung heat flow, so exothermic siya kasi negative siya. Pero pag nakita natin na yung delta H or enthalpy change natin is positive, agad-agad, endothermic siya kasi nag-absorb siya ng heat. So for this example, nakita natin sa kanyang thermochemical equation, negative 890.4 kilojoules. Ibig sabihin, automatic yon, exothermic yung reaction natin. So dagdagan pa natin yung mga heat. So sa mga heat of reaction, ito yung mga common. So lalagyan na rin natin sila ng pangalan dahil sila naman yung common. Meron tayong heat of combustion. Pag combustion, ibig sabihin nun, sinusunog. And that is, nag-a-add tayo ng oxygen doon sa isa pang product. So, usually ito yung tinitignan para ma-compare yung various fuels na kakailanganin mo kung ikaw ay mag-operate sa hydroelectric power. Kasi, syempre, still in pursuit of best ways, di ba? And most efficient ways para makapag-generate, makapag-harness tayo ng energy. So, usually yan yung ginagamit para makita yung heat of combustion ang tinitignan kung maganda ba or efficient ba, maganda ba, malaki yung energy na mapoproduce nung certain fuel na kakailanganin. Meron din tayong tinatawag na heat of neutralization. Ito naman is yung heat kapag nineutralize ng acid yung mga bases or and vice versa. Heat of neutralization. And then meron din tayong tinatawag na heat of formation. So itong heat of formation, meron siyang certain importance. Pag sinabi nating formation reaction, ito yung chemical reaction na yung isang mole ng isang compound ay na-form mula sa kanyang mga elements at standard states. At kapag sinabi nating standard state, usually ito yung pinaka-stable, most stable state nung ating mga elements. And usually that is at room temperature 25 degrees Celsius at ang pressure is 1 atmosphere. Yan. So, formation reaction is chemical reaction by which one mole of compound is formed from its elements in their standard states. Ang standard state natin is 25 degrees Celsius and pressure is 1 atm. So, medyo kakaiba yung kanyang symbol. Balikan lang natin. Yan. Meron siyang degree sign sa superscript. Subscript is F for formation. So, although meron tayong heat of reaction na tinatawag, there is actually hindi natin actually alam kung ano ang nangyayari sa isang chemical reaction. So, ibig sabihin nun is we don't actually know kung paano na-form ang products sa reactants because there are many possible ways. Okay? That means, kunwari meron kang set of reactants or species, they react with each other, and then after some time, they will produce products. We didn't actually know what happened in between. Basta alam natin, okay, at the beginning, ito yung reactants, nag-react sila with each other, they form products. In between the process, marami kasing pwedeng puntahan. But, okay lang, it doesn't matter. Kasi sabi ni Hess law, yung enthalpy change naman sa isang process, independent siya on how a particular way is carried out. Or independent of the particular way the process is carried out. Doesn't matter kung ano ang pinagdaanan ng reactants natin para ma-form yung product. Because the enthalpy change, no matter what process is, kahit gaano pa niyan ginawa, nagtatatumbling man siya o ano, basta same ang beginning reactants, same ang ending products, yung enthalpy change, sabi ni Hess law, ganun pa rin. So, ito yung diagram natin. For example, we have the initial state of a process and we have the final state. So, we know that we have a desired change in enthalpy. But in reality, there are what we call intermediate states. Kumbaga, A, B, or more na pwedeng puntahan yung initial state natin but still end up with the final state. And they can have different initial enthalpy changes and final enthalpy changes. However, kahit ganun pa man, pag pinong-combine natin yung mga yan, still, the enthalpy change ng ating desired enthalpy change doesn't change. Yun yung sabi ni Hess law. Pwede kang maraming puntahan at pagdaanan, pero yung enthalpy change mo, parehas pa rin. It's because enthalpy change is a state function. Pag sinabi nating state function, ito yung mga variables na yung value nila nakadepende doon sa state ng system at hindi doon sa history. Okay? For example, our initial state, for example, nandito ka sa point A and you wish to go to point B. There are many ways to go from point A to point B, right? Pwedeng dyan ka dumaan, pwedeng dito ka dumaan, pwedeng dyan, pwedeng lumiko-liko ka muna bago pumunta. Pero sabi ni Hess law, wala yung pakialam. Kasi si enthalpy naman is state function. Titignan ko lang yung state ng system ko. So kahit saan ka man dumaan dyan, basta't naggaling ka sa A, papunta kay B, yung enthalpy change ko, pare-parehas yan. So kagaya ng, for example, nagda-drive ka sa car, sa kotse, so kung nasaan ka man, yung location, exact location mo, base sa GPS na sabi ng kotse mo, yun yung state function. Yung location is a state function. Sinasabi niya kung nasaan ka. However, yung distance mo from, for example, point A to point B, yung distance is not a state function. Kasi kailangan niya ng pagbabasihan. Titignan niya kung saan ka nang galing. Hindi ganon ang state function. Ang state function, hindi niya tinitignan kung saan ka galing. Ang tinitignan niya kung ano yung estado mo ngayon. Nasaan ka ngayon. Yun yung ibig sabihin nun. So, yun yung basis ng ating Hess law. Bakit meron ng example kaagad? So, let's try to solve an example. You have example 7. Sulfur trioxide reacts with water to form sulfuric acid, a major contributor to acid rain. One origin of sulfur trioxide is the combustion of sulfur, which is present in small quantities in coal, according to the following equation. So, solid state sulfur plus yung gas state ng oxygen, 3/2 moles ng oxygen gas will yield sulfur trioxide in gas state. So, given the thermochemical information below, determine the heat of reaction for this reaction. Hinahanap natin is yung heat of reaction. Ang gusto nating mag-end tayo sa sulfur trioxide. Ito yung gusto natin, desired chemical reaction natin. Makapag-form tayo ng sulfur trioxide sa product para makita natin kung ilan yung enthalpy change nga or yung heat of reaction dito. But ang given lang sa atin is not directly the same kind, no, may mga iba pang siyang pinagdaanan. So we have two thermochemical equations. The first one is solid na sulfur plus oxygen gas will yield sulfur dioxide. So hindi yan yung kailangan natin. Pangalawang thermal equation is 2 moles ng sulfur dioxide plus 1 mole ng oxygen will yield 2 moles ng sulfur trioxide. So nakita natin nandito yung kailangan natin, sulfur trioxide. Yun yung desired natin. However, 2 moles siya. Kailangan natin isa lang. So what we can do is, actually, itong mga thermochemical equations naman ng nasa dulo, thermochemical equations na siya kasi kasama na yung mga heat reaction, no? At standard state sa mga yan kasi meron siyang degree symbol sa taas. Ang kagandahan nito is pwede tayong mag-divide ng constants dun sa kanilang mga coefficients because ang desired natin is 1 mole lang ng sulfur trioxide. Yung heat of reaction lang to produce 1 mole of sulfur trioxide. However, in the given thermochemical informations, we have 2 moles. Dun sa second equation, 2 moles. Magde-divide ako ngayon ng 2 or magmumultiply tayo ng 1/2. And kapag nagmumultiply tayo ng 1/2 doon sa coefficients noong chemical equation or reaction, isasama mo din yung enthalpy change or heat reaction, heat of reaction sa pag-divide. So parang isang buong magkakasama sila, i-divide natin ng 2. Pag dinivide na natin ng 2, syempre makakancel yung 2 na coefficient ni sulfur dioxide in gaseous state. Magkakaroon ngayon ng 1/2 si oxygen gas and will yield sulfur trioxide in gaseous state. So 1 mole na lang siya. At ayun, nakita na natin yung gusto nating makuha. Pero kung mapapansin nyo, hindi pa naman sila parehas kasi yung reactants doon sa desired chemical reaction natin is solid sulfur and oxygen gas. Yung reactants dito sa pangalawang equation after mag-divide tayo ng 2 is sulfur dioxide, oxygen gas. So paano natin gagawin yun? So okay, I'm sorry. I-divide din natin ng 2 yung enthalpy change dito or heat of reaction. So yung negative 197 divided by 2, that is 98.5, negative 98.5 kilojoules. I-divide din natin ng 2 yun. So pag na-divide na natin 2, kakalimutan na natin yung original equation. And ano ang gagawin ko para mapunta ako sa SO3? Ang gagawin ko is i-add ko yung 2 thermochemical equations. Yung una na hindi ko ginalaw, yung pangalawa after ko mag-divide ng 2. So i-write ko siya dun sa next slide dahil wala na akong space dito. Yung first equation is S sulfur oxygen gas will yield sulfur dioxide in gas. Tama ba? Yes. Coefficients, wala. And ang heat reaction niya is negative 296.8 kilojoule. Kukopyahin ko din yung pangalawa, pero yung na-divide na ng 2. Okay? So we have sulfur dioxide gas plus 1/2 oxygen gas, 1/2 mole, and then 1 mole ng sulfur trioxide gas at ang kanyang heat of reaction is negative 98.5 kilojoule. What I can do is actually parang sa math lang, sa algebra, pwede nating i-add tong mga chemical equations na yan, and at the same time yung kanilang heat of reaction. And pwede nating isipin na yung product will cancel out reactants. Yung product sa isang equation, pwede ma-cancel out yung reactants dun sa pangalang equation kung equal sila. So parang isipin natin na they are opposite signs, kumbaga. Kasi tingnan nyo, yung dun sa first equation, thermochemical equation, nasa product si sulfur dioxide, nandito siya. Dun sa second equation, nandoon naman siya sa reactants. So pag pinag-add ko yan, actually magka-cancel out yung dalawang yan. The others, kung walang ma-cancel out, i-add natin yung coefficients kung kailangan. Pero yung sulfur dioxide, makaka-cancel out siya kasi dun sa first equation, product siya. And on the second equation, reactant siya. And since opposite yung direction nilang dalawa, parehas din naman sila ng coefficient which is 1, cancel yun. Then the other species or the other reactants, kokopyahin lang natin. So magbi-bring down tayo ng S. Sulfur, solid. Yung sulfur dioxide makakancel. Okay, wait. Change natin yung kulay para makita natin. Green. Kaka-cancel ito. Ay, sorry. Nawala tuloy. Balik natin. Solid, sulfur dioxide in gas. Palitan natin ng green. Okay. Kaka-cancel out itong sulfur dioxide kasi nasa product and reactant siya sa first and second equation respectively. And then yung sulfur, wala naman siyang katapat, yung sulfur na solid, so bring down lang natin siya. Yung oxygen na gas, meron siya, 'di ba? 1 yung coefficient nung sa equation 1 and 1/2 sa equation 2. Kapag same yan at same na nasa reactants sila, ibig sabihin parang para silang positive, parang ganun. So we just add the coefficients. So 1 and 1/2, that is 3/2. In-add natin yung coefficients. Of course, pag wala kayo nakikita, ibig sabihin nun 1 yung coefficient niya. And then same lang ang gagawin sa product. So wala naman nang natira sa may bandang part ng product kundi SO3 lang or carbon trioxide. Ganun din ang gagawin natin sa mga heat of reaction. I-add din natin sila. Pag in-add natin sila, we will get negative 395.3 kilojoules. At kung mapapansin nyo, ito na actually yung desired chemical reaction natin. Balikan ko yung problem. Yan, ito na siya. Kamukha na siya ng desired chemical reaction natin. At kung nakuha mo na yan, yung katapat niyang heat of reaction, yun na yung hinahanap natin. Yun na yung magiging heat of reaction ng buong chemical reaction with the given, with the desired product na gusto natin. So the answer is delta H or heat of reaction equals negative 395.3 kilojoules. Okay? Linawin lang natin. Ang nangyari kasi, we have a desired chemical reaction and we want to find the heat of reaction with that particular desired chemical reaction. However, hindi natin alam. Pero ang binigyan tayo ng dalawang thermochemical equations, may dalawa tayong information. So what we did is we adjust kung kailangan mag-multiply at mag-divide sa mga coefficients kasama na yung heat of reaction, ginawa natin. And then parang nasa algebra manner, in-add natin yung mga equations so that makuha natin yung desired chemical reaction natin and therefore makuha rin natin yung hinahanap, which is the heat of reaction ng ating chemical reaction na desired. Ganon din yung nangyayari sa formation reaction. Pwede rin nating i-apply yung Hess law sa formation reaction. So yung desired natin na enthalpy change from the initial state to final state, pwede ring merong daanang mga elements in standard state. So, kung meron man tayong hindi naka-standard state, yung enthalpy change niya dapat parehas din. Sa formation reaction, however, kapag kinonsider natin yung elements in standard states, kailangan nating gamitin itong formula na ito. So, ang ibig sabihin lang nito, i-add muna natin lahat ng mga heat of reaction sa product, or i-multiply muna natin yung kanilang mga coefficients. Yung V dito is mga coefficients. So, coefficient ng isang reactant or ng isang product multiplied sa kanyang heat of reaction. And then, yung ibig sabihin ng summation is i-add natin lahat yun. Kung meron tayong maraming products, i-add natin yung mga yun. Yung products ng coefficient niya times yung kanyang heat of reaction. And then, isusubtract natin yan sa products, as in yung product na times ng coefficients ng reactants sa kanyang heat of reaction. Or heat of formation, heat of formation. Kasi meron siyang F. Kasi formation reaction to. For example, ito. Yan, para mas magets natin. Meron tayong given na data. Ngayon, kukunin natin yung heat of combustion ng isang mole ng propane, C3H8, para mag-form siya ng carbon dioxide and liquid water. Given the following heat of formation ng mga species. So, for carbon dioxide, hydrogen in liquid, water in liquid form, and then the propane at saka yung oxygen with their given formation reaction. So, magiging chemical reaction natin or chemical equation is yung propane C3H8. Ang gagawin natin is i-burn down natin siya. Tama? Kailangan merong combustion. So, dadagdagan natin siya ng oxygen. Oxygen gas. Ang propane natin ay naka-gas din. Burahin ko lang siya. Indicate ko lang na gas. So, propane. Dagdagan natin ng oxygen para magkaroon ng combustion. At ang in-expect natin, sabi dun sa problem, magpo-form siya ng gaseous carbon dioxide and liquid water. So, carbon dioxide in gas state and water. So, hindi pa ito yung final. Lalagyan pa siya ng coefficients. So, I hope familiar kayo sa pag-balance ng chemical equation, balancing chemical equations. Hindi ko na siya ituturo dito kasi ina-assume na alam natin. But, yung balance na chemical equation is yan, sa isang mole ng propane, 5 moles ng oxygen ang magre-react to form 3 moles of carbon dioxide and 4 moles of water. So, yan yung balance equation natin. Ang hinahanap natin dito is yung delta H niya or heat formation reaction. Heat of formation yung hinahanap. Okay. Para sa mga formation reaction, ito yung formula. Sabi ng Hess law. Kunin mo yung pag i-multiply mo yung mga coefficients ng product sa kanilang mga heat of formation, tapos i-add mo sila. Isusubtract mo ngayon dyan yung product naman or yung makukuha mong product ng or i-multiply mo yung I tend to not use the term product as in yung multiplication ng A times B bilang product kasi yung product natin ginamit na dito sa words chemistry. So, i-minus mo yung makukuha mo kapag pinag-multiply mo naman yung mga coefficients nung reactants sa kanilang mga heat of formation. Tapos isasum mo sila. So dito sa given example, with the following balance equation, dalawa yung reactants, we have propane and oxygen, and dalawa din yung product, carbon dioxide and water. So sabi ng formula natin is enthalpy change equals, i-multiply mo yung mga coefficients sa may bandang product sa kani-kanilang mga heat of formation, o product minus reactant, from I hanggang sa kung ilan man, minus i-add mo din yung coefficients multiplied to the heat of formation ng mga reactants naman. J hanggang sa kung ilan. So ano ba yung mga product? Unahin natin yung product. Yung product natin is carbon dioxide and water. Ano yung coefficients ng carbon dioxide or coefficient ng carbon dioxide? Yun yung V 3, di ba? 3, yun, 3 moles. So multiply natin yung 3, multiply doon sa ano yung delta HF na mayroong degree sign sa itaas. That is the heat of formation, given yan. Anong heat of formation ng carbon dioxide? We have negative 393.5 kilojoules. So i-multiply natin yon. Negative 393.5 kilojoule per mole. So yung 3 dito, that actually represent 3 moles. Ayan, para ma-cancel lang. Makita natin na mag-cancel yung mole. Isulat ko na din. Yan yung first product. I-add natin yan sa iba pang product. Dalawa lang naman yung product eh. Yung carbon dioxide, yung isa, water. So yung sa may bandang water, 4 moles siya. So 4 moles multiplied by heat of formation ng water is negative 285.8 kilojoule per mole. Negative 285.8 kilojoule per mole. Ayan. So lahat niyan i-add mo muna bago mo i-subtract sa mga reactants naman. Same ang gagawin mo sa reactants. So sa reactants, ito nasa left side, 1 mole ng propane. So 1, sulat ko lang, 1 mole of propane multiplied by yung kanyang heat of formation is negative 103.8 kilojoules per mole plus excuse me, for the oxygen we have 5 moles of oxygen, pero yung heat of formation naman ng oxygen is 0. Sorry, O2 ito O2. So 0 kilojoule per mole. Lagay lang natin para makita natin na convert siya sa joules. Siyempre magzi-0 yan, 5 times 0, 0. So simplify natin, delta H equals, sa itaas we have 3 times negative 393.5 will give us negative 1180.5 plus 4 times negative 285.8 1143.2. So negative. Be careful with yung mga parentheses natin kasi subtraction yung nasa gitna. Dun sa reactants, 1 mole times negative 103, malamang negative 103.8 kilojoule per mole siya. Tapos yung 5 times 0, 0. So simplify pa natin yung nasa loob. We have negative 1180.5 plus negative 1143.2 is negative 2.323.7 kilojoules. And then ito, negative times negative, positive 103.8 kilojoules per mole. Add natin yung dalawang yan. Will give us negative 2219.9 kilojoules. Sorry, kilojoules na lang siya, walang per mole. Yan, negative 2219.9 kilojoules. Yan yung heat of formation ng combustion of propane. Okay. So, lahat ng na-discuss natin as actually sa mga problems, mga examples ng thermochemistry. Meron din tayong tinatawag na electrochemistry. Lahat kasi ng mga nauna natin na-discuss is laging how chemical energy is converted into heat energy, kaya nga thermochemistry. But that is not the only way, or that is not the only option. Chemical energy can also be converted directly into electrical energy. So, yan yung pag-aaralan natin sa electrochemistry. There are other reactions that convert chemical energy into other forms, kagaya ng, actually hindi lang sa electrochemistry, yung mga glow sticks, yung mga fireflies, diba? Yung chemical energy, kino-convert nila, nire-release nila as light. So sa electrochemistry naman, sa mga batteries naman, kino-convert yung chemical energy directly to electrical energy. Yan. At ang tawag natin doon is electrochemistry. So paano ba nako-convert ang chemical energy directly to electrical energy? At bakit some batteries madali silang mamatay, or yung iba namamatay talaga, hindi na magamit. Yung iba naman is nare-recharge natin. So we have to step back and review muna ano bang electrical energy. Electrical energy arises from moving electrons. So magkakaroon lang ng electrical energy and electricity kung gumalaw yung mga electrons. And actually, para mapagana natin yung mga conventional electrical devices natin, kailangan natin i-move yung electrons sa wires, through wire. So kadalasan ginagamit dyan is copper wires, diba? So yun ang aim mo, para magkaroon ka ng electrical energy. Kailangan paggalawin mo muna yung mga electrons, kasi pag hindi sila gumalaw, hindi ka magkakaroon ng electrical energy. Kaya nga electricity, electron, moving electron. So isipin mo ngayon is you will devise a way kung paano yung chemical reactions will produce electrical energy. Paano ngayon mapapagalaw ng isang chemical reaction yung mga electrons that make up the species or yung mga substances, elements na nandoon sa chemical reaction na yun. So parang sa madaling sabi, yung chemical reaction natin, siya yung parang magsisilbing source natin ng moving electrons. Pero tandaan din natin that electrons or electrical charges must also be conserved. So para yung mga charges makapag-move sila, mag-move lang sila dapat sa isang closed path or sa isang cycle or sa isang closed circuit na tinatawag. Okay? Law of conservation of charges yon. So ang gagawin natin, isipin mo, sa isang battery, ang nangyayari is that yung electrons ay nare-release sa isang terminal Kaya nga 'di ba merong dalawang terminal yung battery natin. Kapag nabaliktad yung battery, hindi gumagana. Why? Because specific yung trabaho ng dalawang terminals na yun. Dun sa isang terminal, marirelease yung mga electron. Gagalaw sila and that will form or that will release energy. Electrical energy. Sa paggalaw nilang yun, kung marirelease sila, i-recapture naman sila doon sa kabilang side ng terminal para makomplete yung circuit, and therefore bumalik yung mga charges. Nasunod natin yung law of conservation of charges. Ganun ang basically, at a nutshell, ganun ang nangyayari sa ang battery. Binabato natin, nire-release natin yung electrons at one terminal, dadaan siya sa mga wires para gumalaw, pupunta doon sa device na gusto nating i-power, and then babalik siya ulit doon sa kabilang side ng battery para ma-conserve yung charges at makapag-create ng closed circuit or closed path. Pero yung concept and how does a chemical reaction produces or moves electricity or electrons, ang concept na ginagamit na is yung tinatawag nating redox reaction. So what is a redox reaction? Yung redox is simply short for oxidation reduction reaction, and it involves the transfer of electrons from one species to another. So for example, ganito ang nangyayari sa isang standard alkaline battery. So mapapansin natin dun sa chemical reaction, meron tayong zinc, meron tayong manganese dioxide, meron tayong water. Yun yung mga reactants, and they form zinc oxide and manganese hydroxide solid. So, yan yung nasa loob ng ating standard alkaline battery. Nakaseparate, kung mapapansin natin, nakaseparate yung zinc. Yung zinc natin ito, yung kulay blue, that is the powdered zinc. Tapos, yung ating manganese dioxide at saka carbon, etong medyo grayish green or greenish gray, kumbaga. Merong nagsiseparate sa kanila, which is a separator, a non-woven fabric. Yung zinc ay sinadya talagang i-separate sa manganese dioxide para yung electrons ay matransfer, it will flow out papunta sa external circuit, papasok naman doon sa, then babalik siya doon, papasok dito sa kabilang terminal naman nung battery. So yung chemical reaction natin sa taas or chemical equation represents yung ating reaction na nangyayari. And the question is, paano ngayon itong reaction na to nag-i-involve ng transfer ng electrons? So kung titingnan natin, meron tayong zinc and manganese on each side of the equation. So kapag ititreat natin si zinc oxide doon sa product na parang ionic compound, ibig sabihin nun, sana alam nyo pa kung anong ibig sabihin ng ionic compound, diba? Meron tayong ions, kumbaga zinc ion, oxygen ion. Yung zinc, kailangan niya ng positive 2 na charge para mabalanse yung negative 2 na charge nung oxygen. And ano bang ibig sabihin natin doon sa ion? So i-review lang natin, di ba? Ions are simply unbalanced charges, or there is an unbalance in charge or in number of electrons sa isang element. So kasi kung sa stable state, for example, 8, so 8 yung electron sa outermost shell. Kung nakompleto mo yung 8, nasa stable state ka. Pag nabawasan ka ng electron, ibig sabihin, originally, sa loob ng isang atom, equal yung number of protons na nasa nucleus, inside the nucleus, sa electrons na nasa labas ng nucleus. Pag nadagdagan ka ng isang electron, hindi na yun balance, 'di ba? Mas madami ka ng electron, so yung net charge ng element natin nagiging negative siya. Yun yung tinatawag nating negative ion or negatively charged ion, anion, kasi mas madami yung electron. Pero pag nabawasan ka ng electron, mas marami na ngayon yung number of protons kaysa sa electron, nagiging positively charged ion ka or cation. So dito, yung zinc, sa zinc oxide sa product, kailangan niya ng positive 2 na charge para mabalance yung negative 2 charge ng oxygen. But ang ibig sabihin actually ng kailangan niya ng positive 2 na charge is that kailangan niyang mag-release ng electron, ng dalawang electrons para maging unbalance siya at mas madami na yung positive kaysa sa electron. Magbabawas siya ng electron. Yun yung ibig sabihin ng kailangan niya ng positive 2 na charge. So, kapag nag-react yung zinc na metal para makapag-form ng zinc oxide, lahat ng atom ng zinc na nagre-react, maglo-lose sila ngayon ng dalawang electron. Ganon din ang nangyayari dun sa manganese. Manganese 4, di ba? Manganese 4 dioxide. Kailangan niya naman ng 4, positive 4 na charge. So, ibig sabihin kailangan niyang from yung manganese oxide naging manganese hydroxide. So from 4 positive 4 magiging positive 2 lang siya. So ibig sabihin kailangan niyang from positive 4 maging positive 2. Kailangan niyang magbawas ng charge. Ibig sabihin lang doon, kailangan mas maging more negative siya. Kapag kailangan mong maging more negative, kailangan mong magdagdag ng dalawang electron, 'di ba? Kasi 4 minus 2 equals positive 2. So yung minus 2, ang ibig sabihin nun, kailangan niya mag-gain ng dalawang electron. Pag nag-gain siya ng dalawang electron, mas nagiging negative siya. Okay? Saan yun manggagaling? Doon yun sa na-release kanina na zinc. Si zinc, kailangan niya mag-lose ng dalawang electron. Si manganese, kailangan niyang mag-gain ng dalawang electron. Doon yung nangyayari yung cycle. Lahat ng zinc atoms, magbabawas ng electron. Si manganese, mag-accept ng dalawang electron. Lahat ng electrons ilalabas ni zinc papunta sa external circuit. Para mabuo yung circuit, babalik siya dito. Pero pagbalik niya, sino nang magsasalo? Si manganese na, para mabuo yung redox or yung oxidation reduction na reaction. Magtatanggal si zinc, magtatanggal ng dalawang electron. Ibig sabihin napamove niya na yung mga electrons. Lalabas yan papunta sa wire, at ang tendency ng electrons, maghahanap sila ng mag-accept sa kanila. Maghahanap niya ng mga orbitals, ng mga butas. Sino ba ang meron at willing mag-accept? Yung manganese. Nag-aantay lang siya ng dalawa. Doon na yan. So, aantayin niya siya dito sa kabilang terminal. So, meron kang giver, si zinc, taga-bigay. Si manganese, sa cathode, taga-accept ng electrons. Kaya ngayon, nabubuo yung isang cycle, isang circuit. Dahil dyan. Sa mga ganitong redox reaction, yung energy change, yung delta H natin dito, siya yung nagfi-fix ng voltage sa mga electrochemical cell. Kasi syempre at beginning, pagkagawa nung meron lang amount of substance na nandiyan. So yung energy change, fix lang din siya. Yun, doon nakadepende kung anong magiging voltage output ng isang electrochemical cell. Pero yung mga ibang batteries, pwede nating i-combine sila, i-arrange natin sila sa mga multiple cells para ma-increase natin yung effective voltage. Actually, ito yung ginagawa sa mga battery ng kotse. So kung mapapansin nyo yung loob ng battery ng kotse, maraming mga maliliit na batteries yun para ma-increase yung effective voltage niya. Okay. May dalawang klase ng batteries. Meron tayong tinatawag na primary battery at ito yung mga non-rechargeable. Sila yung useless na kapag natapos na lahat ng chemical reaction. So, bawat gamit mo, nagre-redox reaction siya, pero once na naubos na yung pwede niyang magawang reaction, mamamatay na yung battery natin at hindi na natin siya magagamit. So, ang tawag natin sa mga non-rechargeable battery ay zinc battery. So, example niyan, yung zinc air, yung alkaline kanina na in-example natin, yan yung mga non-rechargeable batteries. So, yung lifetime ng isang primary battery, nagdedepende lang sa kung ilan yung amount ng reactants na nandoon na present pa sa loob ng battery. Kaya nga, kung i-compare natin ang isang diesel na primary battery at saka yung AA na primary battery, mas madaling maubos yung or mas madaling mawala ng energy, maubos yung charge ng AA kasi pag kinompare mo yung size, mas malaki. Syempre kung mas malaki yung size ng diesel, mas maraming yung amount ng substance na kaya niyang ma-handle or mailagay dun sa volume niya. At kung mas maraming amount ng substance, mas mahaba ngayon yung lifetime ng battery kasi mas marami siyang redox reaction na magagawa. Okay. Mamamatay lang yung mga ganitong klase ng battery kung lahat na ng reactants ay na-convert na at nagawa ng product. At yung kanilang mga voltage output, usually kapag malapit na silang mamatay, bumababa na din yung kanilang voltage output habang nalalapit na sila sa kanilang end ng lifetime nila. Yung pangalawang klase ng battery naman is yung tinatawag nating secondary battery. So ito naman yung mga rechargeable batteries. So kung isipin natin sa redox reaction, yan, magkakaroon ng reactant. Yung reactants magbibigay ng, pag nag-react malamang may product. Pag naubos na yung reactants, magiging product na silang lahat. So para maging rechargeable siya, kailangan ma-reverse natin yung process. That means kailangan yung mga product maibalik natin at maging reactant ulit sila. Kailangan nating ma-reverse yung redox reaction. Ganun ang ginagawa ng secondary batteries. Nire-reverse niya yung redox reaction. But to be able to do that, kailangan natin ng external energy na magtutulak sa mga species natin, sa mga electrons natin from product at gawin siyang reactant ulit. O kailangan niya kasing ma-convert yung products ulit papunta sa reactant para meron ulit redox reaction. Kasi dun sa primary battery, di ba, matatapos lang yung buhay ng battery pag wala na siyang reactants. Eh kung kaya mo namang ibalik yung mga products pabalik sa reactants, magiging secondary battery siya, rechargeable na siya. So much longer na yung life cycle niya. Since lahat naman ng reaction ay exothermic, kailangan nating mag-supply ng energy para ma-reverse yung reaction. Kaya nga yung word na rechargeable, di ba? Para ma-recharge yung batteries, sinasaksak natin sila sa external energy supply. So, meron yang mga chargers, di ba? Yung chargers, sila ngayon magsusupply ng energy para maibalik o matulak ulit, mai-reverse ngayon yung redox reaction. Yung battery charger natin, gumagamit yun ng electrical energy from other sources, kagaya ng saksakan natin, yung outlet natin. So, ida-drive niya yung redox reaction uphill, energetically uphill direction. Ganon ang nangyayari. sa secondary batteries. Kung bakit sila rechargeable? Kasi nire-reverse nila yung redox reaction with the help of external sources, kagaya ng kuryente ng outlet natin. So ito yung mga common. This is a comparison of common primary batteries and rechargeable batteries or secondary batteries. Yung common sa primary is zinc, air, alkaline, and lithium. Rechargeable naman, nickel, cadmium, nickel metal hydride, and lithium ion. Maraming attributes na kailangan i-consider when comparing batteries, like yung energy density, storage density, cost, safety, environment. Yan yung mga kailangan nating tignan, and depende sa paggagamitan mo kung ikaw ay magde-design. So kailangan mo tignan itong comparison na to, depende sa pag-fit nung niya sa system mo. So thank you, that is all for lesson number 1, energy. If you have any questions, you can find me at these accounts, or you can email me sa mjrepair@cdd.edu.ph. Pwede nyo rin akong i-PM sa Messenger. Thank you, and study smart.